Hi everybody, this is Robert Hodges. I'm CEO of Altinity, and I'm going to be talking about ClickHouse and speed. The title of this short video is How Fast is ClickHouse-Fast? To find out, we're going to actually need to run some queries. So what I'd like to do is go ahead and fire up our favorite client, the ClickHouse client, and connect to a database that has 1.3 billion rows of taxicab data. Let's go ahead and start it. So we're connected to ClickHouse version 20.3, and for those of you who are database gurus and think about performance, we have a special setting so that any query that goes to real data is going to skip cache and only read from storage. This is important because it gives us realistic numbers on how fast ClickHouse can do I/O. Let's kick things off by counting the amount of data that we have in this data set. I'm going to pull up a query that does a count on it. We'll run it, and it completes almost instantly. Now, we don't take a lot of pride in that, even though it is fast, because there are many ways that databases can do a count quickly. What's interesting here is the number of rows. And the reason we want this number is it sets us up to do an interesting experiment. What would happen and how long would it take if we were to compute the average of numbers starting from 1 and going to 1.3 billion entirely in memory? Let's go ahead and run that query, which we can do with ClickHouse using a magic table called system.numbersmt. I'm going to kick that query off, and we get an answer within about 1.5 seconds. That's not too bad, but it now sets us up to ask the question, well, what if we ask a similar question to real data? So I'm now going to run a query which is going to count the average number of passengers per taxi over that 1.3 billion taxicab data set. And while this query is running, you might think to yourself, what runs faster, a query operating entirely on data in memory or a query that must go to storage to fetch it out? Let's find out. Of course, you have to think pretty quickly because this query in fact runs in 1/3 of the time of the memory example that we just tried out. There's a lot to unpack here about why ClickHouse is so quick on it, but it really comes down to one thing in this particular case. ClickHouse is extremely efficient at parallelizing I/O. The data that we're scanning is stored in columns. ClickHouse is a column store. It's highly compressed, and ClickHouse is extremely good at dividing that column up into pieces and farming it out to 8 vCPUs, which are running on this VM. So even though we have to take a hop across the network to talk to EBS storage, elastic block storage, we still are far faster than computing this average in memory. That answers part of the question about what we mean by ClickHouse-Fast. Basically, this means that analysts who are asking open-ended queries don't sit around waiting for the database. It does bring up a question, though. What if your user is not a human, but a machine of some kind? For example, an application that's trying to put something up on a web page, or another application that's trying to react to market data. In this case, we need answers not in seconds, but in milliseconds, ideally 10 milliseconds or less. It turns out that ClickHouse can do this as well. The way we do it is create a materialized view. And a materialized view computes at least part of the aggregates that we're asking about. In this case, the materialized view has already computed the average number of passengers per day. We can go ahead and scan that and get the number for the entire data set. So let's go ahead and do that. And what we see here is in this case, where we've done a little bit of extra work, the query now runs in 2 milliseconds. So with these two examples, we see what people mean when they talk about ClickHouse-Fast. Ad hoc queries that complete in less than a second, and CAN queries which can complete in 10 milliseconds or less. That's ClickHouse-Fast. I hope you've enjoyed this video. We're from Altinity, and if you'd like to find out more, please contact us. We'd love to talk to you. Thanks, and have a great day.